All right, folks, it's Bass Action back in action here. In this video, we are going to work through average rate of change working with the trig function. Now, I know that you're not familiar with what these trig functions look like, so these are going to be a little harder for us to, we can't really visualize them right now. But we're just going to work on the algebra with this. This is going to give us an opportunity to practice with average rate of change and evaluating our unit circle. These are going to be really, really strange looking answers when we're done, so don't let that scare you. As a reminder, when we see the values that are placed right here, notice these are not parentheses. This is an interval of x values. So before we can find average rate of change that we remember as slope, we need to evaluate our function at each of these two numbers. Now, there's some notation that's going to be pretty important on this, so pay attention here. It is things that I will also be looking for when I grade your papers. So first things first, we're going to evaluate, and let's keep good track of what we're doing. Remember, all calculations have to be labeled or you will lose points. So f of 0, we're evaluating this first one right here, is secant of 0. Now, those zeros sometimes get tricky. That means that it's a rotation of 0. So we're at that point on the unit circle. That ordered pair is 1, 0. So secant of a rotation of 0 degrees. This is the reciprocal of cosine. Cosine would have been the x-coordinate. The reciprocal of x is 1. So the secant of 0 radians or 0 degrees is 1. That means that I have the ordered pair 0, 1. That 0 is coming from this 0. That's not what I meant to do. Let's see if we can undo that. There we go. Let's go back. That was crazy. I was trying to highlight there, but that didn't work out. Let's try a different thing. It comes from this 0 and this 1 is creating this ordered pair. Let's do this again. I will not be doing that highlight again. We're going to do f of pi over 6. That means we want to evaluate secant at pi over 6. Secant is the reciprocal of cosine. The x-coordinate at pi over 6 would be radical 3 over 2. So its reciprocal is 2 radical 3 over 3. Now that's going to create the ordered pair pi over 6, 2 radical 3 over 3. Now we're going to find our average rate of change between these 2 points. Remember, all calculations have to be labeled. So I'm going to write ARC. You could write ROC for just rate of change. You could even write an M and I would be happy, but you got to label it somehow what we're doing. Now, we're going to start our subtraction. So we'll have our 2 radical 3 over 3 minus 1, and as soon as I have a fraction minus a whole number, I always put that number over 1. It's just going to make things easier in a minute. That's all divided by pi over 6 minus 0. We really don't have to write the minus 0 if we don't want to. We could just write pi over 6. Now, personal preference, I like to use the strategy where we make all of our denominators the same, so then they can all just cancel. So I need all of these denominators to be a 6. So I'm going to multiply. 2 radical 3 over 3 will get multiplied by 2 over 2. This becomes 6 over 6. And of course, this denominator is already 6. That means that in my next step, I will have 2 times 2 radical 3, or 4 radical 3, minus the 6, all over pi, and everything now is automatically done, and I don't have to deal with any other fractions. So I just think that that strategy is kind of nice. Now the next one's going to get a little tricky. Again, we need to calculate our values here. So these are the x values that are going to go into our function, but this 2x is going to make things different for us. We won't notice it right away, but it is going to change things. First things first, f of 0 is tangent of 2 times 0, which is tangent of 0, remember, that's sitting right there on the x-axis. We know that tangent is slope. The slope of the x-axis is 0, so tangent of 0 is 0. So this 0 and this 0 become an ordered pair of 0, 0. Now we're going to do f of pi over 6, which says that our function, tangent of 2x, is 2 over 1 times pi over 6, which says we're really evaluating tangent of pi over 3. This is where it gets tricky. The x value is pi over 6, but when we evaluate the unit circle, it's at pi over 3. Tangent of pi over 3 is radical 3. So the ordered pair is pi over 6. From back here, this is where labeling your work is also helpful. And square root of 3. This is what we're evaluating. So now our average rate of change, radical 3 minus 0, we don't really even need to write it. We don't need to write the minus. Pi over 6 minus 0. Sometimes this throws students off. You could take this numerator and do that whole denominator thing here. Make this denominator the same as this denominator. So rewrite this as 6 radical 3 over 6. Sometimes that's a really handy way for students to do that, which gets us to, those would then cancel, 6 radical 3 over pi. And that is our final answer. Okay, just because I've got time in a video, I'm just going to go ahead and I'm going to show the setup for the next one, because this one's pretty beefy. So I'm just going to go ahead and do it. And if you want to stop at this point, you're more than welcome to, and you can just practice these other ones on your own. This one is a little tricky though, so let's just go ahead and make a video for it anyways. All right. We have f of 2 pi over 9. That's this. It's going to go into our function. That's going to be 4 times cosine of 3 over 1 times 2 pi over 9. That means that these 3's will cancel. That 3 will cancel and will reduce. So what I'm really going to have is 4 times cosine of 2 pi over 3. But that means I'm going to evaluate cosine of 2 pi over 3. Cosine of 2 pi over 3 is going to be 1/2, but it's negative. So now I have this 4 times the negative 1/2, which gets me to a negative 2. Now, I've written out all of the steps. There is a way to kind of condense this work a little bit better, but if you're worried about messing something up, this is a nice way to do it. Next, I'm going to do f of 5 pi over 18, which is 4, times cosine, don't forget that 3 over 1, times 5 pi over 18. Let's reduce our fractions. 3 will go into 18 6 times. So now I'm really evaluating 4 times cosine of 5 pi over 6, which is 4. 5 pi over 6 is in the second quadrant, so it's going to be negative, but now the value is going to change. It will be negative radical 3 over 2. These will reduce, which gets us to a negative 2 radical 3. So now the ordered pairs that we're working with are going to be 2 pi over 9 has to come from the original interval, comma, negative 2, and 5 pi over 18, comma, negative 2 radical 3. Now let's start that average rate of change. Negative 2 radical 3 minus this negative, will be plus 2. And in the denominator, I will have 5 pi, oops, switched colors there, I didn't mean to, 5 pi over 18 minus 2 pi over 9. Again, I like the whole common denominator thing, so I'm going to multiply this one top and bottom by 2. I'm going to multiply the numerator by 18 over 18. So this 18 and all of these will cancel. So my final answer is 18 times this whole numerator, so negative 36 radical 3 plus 36 all over 5 pi minus 4 pi, which is just pi. So that one is a lot. It's pretty tricky, but some things that you should remember. These values here have to be the values in the ordered pair, and this also shows us what we do when we've got something else out front of our function. We just evaluate that unit circle and then multiply the answer by that coefficient. So just it was another option for you to watch in case you needed it.